Questions like this, guys, which involve finding angles of elevation or depression for real life scenarios, actually come up pretty often in exams, and not many people at all get them right. However, the truth is that if you know how to do your so-called tower, then you should be getting these ones. Let's have a look. The question here says, given the following diagram of a boat and lighthouse, find the angle of elevation from the boat to the lighthouse. Guys, angle of elevation, what does it mean? It means that we want to find the angle between this horizontal line down at the bottom and the top of the lighthouse. We can see that we have this horizontal line here drawn for us. Not horizontal, I actually meant diagonal. Yeah, this diagonal line here drawn for us. We also have two lengths, 1.4 kilometers is the length of this diagonal line, and then 1 kilometer is the length of this horizontal distance at the bottom. Guys, what do? What we're going to do is we're going to turn this situation into one in which we have a right angled triangle. We're going to draw a straight line over the dotted line that they've given us. We're going to draw a line over our horizontal situation, and then we are also going to draw a line from the base of the lighthouse up to the top of the lighthouse. Let me just redraw that one, getting it nice and straight to make things clear. We essentially have a right angle triangle like this, and this here is going to be our right angle. Now that we have our right angle, guys, we might be able to spot, finding this angle here, that we have a so-called tower situation. We have a right angle triangle, we've been given two side lengths, and we want to find an angle. Step number one, we're going to label our side lengths. We have the side opposite the angle. We have the hypotenuse, which is opposite our right angle, and we have our adjacent side, which is next to our angle. Next step, based on the two side lengths that we have, we're going to select either so, car, or tower. We can see that the two side lengths that we have here, guys, are the adjacent side of 1 and the hypotenuse of 1.4. Because we have the adjacent and the hypotenuse, we're going to be using car. That is the one that has the adjacent and the hypotenuse. What does car stand for, guys? It stands for cos of our angle, in this case x, is equal to our adjacent side divided by our hypotenuse. In this case, our adjacent side is the one next to the angle of 1, and the hypotenuse is the side length opposite the right angle. It is going to be 1.4. So we can say that cos of our angle is equal to 1 over 1.4, and from there, guys, to find the size of x, we just need to do cos to the minus 1 of both sides. We're going to get that x is equal to inverse cos of 1 over 1.4. This, guys, is something we can bing into our calculator. I'm just going to move my head so you can see it on the vertical video if you're watching over there. Cos to the minus 1 of 1 over 1.4, guys. Let me just type that into the calculator. When we do so, we are going to get 44.42 to 2 decimal places, 44.42 to 2 decimal places. That, guys, is going to be our angle of elevation. Just a quick recap. What did we do there? We firstly converted it into a right angled triangle, and then we used our so-called tower to find our angle. Now, if the so-called tower part confused you, consider watching the video dedicated to using so-called tower to find angles in right angled triangles.